Okay, so we started with our programming with language of data science in terms of the ranking based on the survey of data mining expert, the advantage of using R, importantly some features that we highlighted here being open source, specifically for data analysis, statistical computing, covering thousands of packages. It can be integrated with different programming languages and platform, portable, have some object-oriented programming facilities. It has command line and RStudio. So for the packages, for the whole R, I mentioned that you have to install first R from the crown and then install the RStudio. For any packages that you are going to use in the future, you have to use the command install.package and then the name of the library. I'll provide you some example later. And then for using any function, any libraries, you have to, or packages, sorry, use library and the name of the package. So all the information and updates would be through the comprehensive or archive network or CRAN. So this is the console for command line interface, which you can run your code here or create a new file here. You can clean the console by Control-Enter using the first line of the first command print. Case sensitive of R programming. These are some information using help.start. So started with this part, RStudio, again console. You created in lab session a new RScript file for the beginning. Here you can have the environment here, and you can see all the objects that you upload in the memory would be here. Also, you will have this section which you can install packages through this section or by the command. You can actually clean this section environment by using this brush. Also, some notes for installing R and RStudio. If you have any problem, let me know. We've been till here, which we mentioned that all the variables in R programming would be object. Okay. It could be any simple variable. It could be vectors, lists, matrices, arrays, factors, and data. Okay, we're gonna go for vectors today. So these are, before going to the vectors, we need to know this couple of command or function here. The first one, get working directory, set working directory. So when you're working in RStudio, you will face with RStudio actually assuming a specific default working directory in which it loads or saves all the information from the disk or onto disk from a specific path. So when you're using get WD or get working directory by this function from the console, when you run this, it provides you the default something like this in my computer, for instance. But if you want to, when you save any CSV file, any plot, etc. on a specific directory, you can actually use set working directory and put in your path on your hard disk here with the double quote. So again, when you, for the first time, actually closing the RStudio asking you that do you want to save the whole environment including objects, etc., and you can actually save it for the next time when you run RStudio. It could be loaded automatically in case you have some analysis and some objects in memory. So, but at the same time, you can actually use save.image, and then with your name, any name that you're interested, with the extension of our data, you can actually save the whole environment of RStudio, including objects, into our data. But if you already set working directory in this folder, this R data will save your environment in this folder, okay? So, or when you run RStudio for the first time, you can actually use load and upload this R data, including objects environment, into your memory, okay? So you can actually use the quit function for when you're gonna quit the R with save no. It means you are not actually we avoid or asking again whether you should save the workspace or not with this command. Okay, any question on this page? So, we're going to go for the vectors. Here we have some examples. The definition of vector is a string of numbers, sequential numbers, random numbers, or something like this. So, if you, for instance, in the console, this is the prompt of console, this prompt, I use vector. We can actually create different ways to create a vector. One way is using the command vector with length of 10 and by double. It means we're going to create a vector of 10 numbers with the data type of double. Or if you use without actually mode option, mode parameter, it actually provides you a logical vector, okay, with the initial value of box. Or the easiest way for creating a vector here, as you can see, using the C command, which is combine, and providing 10, 0, the easiest way to create a vector, instead of using this line, okay? So, or even actually easier, if you use rip, which replicate elements of vector. So, replicate 10 elements with the value of 0. It creates a vector of 10 elements with the value of 0. Exactly similar to, in R, there are different ways of doing one specific task. So, and it's the flexibility of R programming, which is interesting. So, or you can actually have using the colon operator, 1 to 10, 1 to 100, and it creates a sequence of numbers, it's consecutive numbers from 1 to 100. Okay? Right. Next one. Again, this one, I'm going to use SEQ or sequence. 8 to 20. Length out is the parameter that as soon as you write length dot out with tab, it provides you the rest of the parameters, and you put it 6. So 826 is the input parameters that you put it. It creates a vector of 6 numbers between 8 and 20. Okay, the splits this range for getting 6 numbers. If you want to access to any element of vectors, for instance the third one, you use the brackets, this type of bracket, it's vector 3 and 1 to 3, the third element would be this. Okay, how can we access to second and fourth element of X vector? x vector, x underscore vector, 4. Is this comment correct? You're gonna access to second and fourth element of this vector. My question is this comment correct call or not? No, if you put it this way, you can get this error. So, because it's similar to accessing to other dimension of the vector, which is not correct. So you have to use C to access to second and the fourth element of vector. Okay. So now the question is how to access to all elements but first element. Let's say we have how many? Six elements in this vector. We're going to access to all of them from 2 to 6, but 1. So the easiest answer is using -1. If you're using -1, it means showing all or providing all elements except index number 1. And even actually I think we could actually use C combined and -1. Even you can actually use this way. Even I prefer this way. Or if you want to exclude just the first and fifth element, you can actually use, this is x underscore vector, x underscore vector C minus would be here, 2, 4. So accessing to all elements but 2 and so using type of function, we could access to a variable or object data type. Okay, so here if you use type of x vector, or you can actually also use length to actually get you the number of elements of a vector. So as you can see here, we have type of, what is the type of x vector here? The double, is it? And the length of x vector is already we mentioned here, 6. What about this, real numbers? What would be when we're running this line? X underscore vector combined 2.1, 4.5. What about this one? Well, I have the answer here. Real numbers are truncated to integer. It means because this is the index of accessing to vector, so it's just considered 2 and 4. And what about this one? Again, we can have a vector of different data type. Logical, a string, and double. Yes? So what is important again here is the single quote versus double quote. If you're using double quote, you will get error. So you have to use single quote for. And again, type of x vector underscore character, which perhaps it would be a type of character. So let's see the answer. Double for x vector in terms of the data type. When you run this line, when you run this length x underscore vector, the answer would be 6. Again, here would be the second and fourth element of the vector by accessing in this type of using index. So, and also again here the type of this variable character. And as you can see from these examples that I provide you, I'm used to writing this type of names. I don't write one X or A or B, except just some example from the web. But for my writing or programming, I'm always using the meaningful names for variables. Okay, try to, for individual coursework, try to use the proper name, not just X, Y, Z. This is meaningless. Use the proper. It doesn't matter how long. I have some names with 50 characters, 100 characters, because when I'm seeing the name of the variable, I can see what's the idea behind using this variable. Okay, so try to use underscore instead of dot. Why? You can actually use dot, but why not dot? Because in object-oriented programming, we're using this dot for accessing to methods, etc. So I would prefer using underscore, not dash. Underscore for, because there are some protocols, some standard for using a proper name in R as well. It's similar to many programming languages. The last line here again, I'm creating a vector of sequence number from 1 to 3 increased by 0.2, okay, which actually creating this number from 1 to 3, but it incremented by 0.2. Okay, any question? Happy with this? Okay, so next one, I created exvec logic. It means a variable, perhaps it's going to be logic. So with some initial values, 1, 2, 3, 4, 5 values, and when I actually run this variable, I'm getting this initial value. The type of this variable creating of logical, and the length is 5. Okay, logical, double, character. So these are the data types that we so far actually learned. Okay, so these are, I'm sure, in the last week we played with this command, etc. But so we formally actually reviewing all of these commands. Okay, don't worry about any part that you are not familiar. I'm covering all of these concepts here. So we have these operators: arithmetic, relational, logical, assignment, and miscellaneous operators, the same as any other programming languages. As you can see here, plus, minus, multiplication, division, person, slash person. What do you call this? Sorry? It's for power, but yeah, or half or something. So this is for relational operators: less than, greater than, equal, less than equal, greater than equal, and is not equal. So for logical, ampersand, double ampersand, pipe, double pipe. Assignment, which you may use equal or the second one, yes? So you can use any of these assignment operators, right? Or these are three other operators. Column, which you saw in vector, we use it for creating a sequence of numbers. Percent in percent, star, percent. Okay, so we're gonna see some example of all of these operators. As I said here, this till here is similar to most, I'm guessing this one as well. Most programming languages have the same a plus b minus b times b divided by b. This is actually provide you a reminder, a percent b, providing you the reminder of division a divided by b. Okay, this providing you the quotient from the division of first operand and the second, and this one providing a power b. Okay, so here some examples. Let's say exceptionally I use AB here, which I don't like it, but just two numbers, 7.2. I use this assignment, B is 2, and then print all of these values, corresponding result. It doesn't matter if you put it a space here, but I'm not usually put it a space between print and parentheses or brackets, but here actually you can see that again it allows you to put it a function with a space and parentheses here. So addition, subtraction, multiplication, division, reminder, quotient, 7.5 divided by 2, which is quotient would be 3, and a power b, 7.5 power 2, which creating 56.25. Okay, so interesting part is you can use these operators for vector as well. It means if you have a with c, three values with a is a double vector of with the initial value of 8, 9, 6, and b again 2, 4, 5. So we can actually use this operator for this vector as well. As you can see, correspondingly actually added a 2, 9, 4, 6, 5 for subtraction again. Index by index, the first element addition, the second, the third, and also for the remainder quotient and power. Okay, for instance, for power a power b is going to be 8 power 2, which is 64, 9 power 4, this number, 6 power 5, this number. Okay. Right, this is relational operators. Relational operators, again, similar to other programming, a less than b, greater than b, a is a equal b, is the first operand less than equal, greater than equal, and not equal, exclamation mark and equal. Okay, so these operators, relational operators, would be useful in any type of conditional, for, while, loop, or similar, when or if you want to compare any number, a string, etc. Okay, so again we have some example here. Print if a less than b. The result is a logical result, is true or false, because this is a condition expression. A is 7.5, b is 2, the result is false. A greater than b, a equal b, a less than b, a greater than b, a not equal to. Okay, and again similarly we have for vectors, which is again index by index, one first elements compare, second element compare, the third, and etc. Could be any vector with any length. Okay, and the result, as you can see, is going to be a vectorized result of true or false. Okay, this is logical operators. We have ampersand, we have pipe, we have exclamation, ampersand, ampersand, and double pipe. Okay, so element-wise logical operand. Let's see some example here. So we have just two values, 0 and 2, because we are going to use in using logical operators. 0 actually is considered as false. Anything else considered as a true. Okay. So and when you check with this, A comparing A and B, it's an AND operation. So the result would be false. It's an OR operation between false and true. Not A would be true. A and B, this is logical and consolidated for all elements. I'll explain in the next slides what's the difference between this. And A for this case is no difference. So A or B, true. For this case, ampersand and ampersand is similar. But when you have a vector, it's going to be okay. So here again we have two vectors, logical vectors, okay, true with these values, true, true, false, false, true, false, true, false. You can use just T at F instead of writing true or false. But here actually I mentioned full. So as you can see, ampersand here providing you a vector of the result. It means it compares the first element versus the first element of second vector. True and true is going to be true, true and false, 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 false. Okay? Why? For this one actually it's creating the whole. It's comparing all of this, and if it's find one of the result actually true, the result would be for this case actually true, because we have the ampersand of one of cases actually true. So let me show you another example, maybe clarify this question. So if we had these two common, so let's say we have a expression, conditional expression, -2 to 2 greater than 0, ampersand -2 to 2 less than 0. We know that -2 to 2 actually creating these vectors, yes? So it says that we're gonna see if this is true and this is true or false, and versus double ampersand. Okay, so as you can see here for 1 ampersand is vectorized. It means it provides you all the individual result of comparing the result of logical expression of these vectors. For instance, if this is greater than 0, so -2 is not greater than 0, so it's going to be false. So again, -2 for this one, less than 0 for the second one is true, false, and true, creating false. Again, the second one, -1 greater than 0, no, false. -1 less than 0, yes, true. Again, false and true, creating false. And similarly for the rest. So for the 0, if 0 greater than 0, yes, true. Again, for this one, 0 less than 0, less than equal 0, true, 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 creating this true. Okay. So it provided a vector of each individual comparison of two vectors. But for this one, it's just creating the final ampersand, the final actually AND operation for the vectors. Okay, so these are assignment operators. Again, there's not much difference between all of this in terms of just the order of using this. So as you can see, you can use equal. I would prefer mostly actually less than dash as an operator, or you can actually use dash greater than, which you assign your value from to the right hand side variable, again you can use this assigned number or this one. Okay, here actually you assign this value, this vector to A. Okay, so this is an example of again assignment operator. So equal, less than, dash, again, and printing the values here. Okay. So the last one is miscellaneous operators. We have column, I already mentioned. You can actually use this operator to create a sequence of numbers. This is really useful operator that you can use in anywhere, including when you're actually dealing with a data frame and specifically with the index. You can use these operators in an index of data frame. So, and this type of actually operators give you a flexibility to write, instead of a couple of lines of code, it's just one line of code. Okay, so identifies if an elements, for instance, for this case, A belongs to vector B. Yeah, or this one is person performs multiplication of a vector with its transpose. Technically, it creates a multiplication of A and transpose of A. Transpose of a matrix is when we switch the row and column of a matrix. Okay, and you can use easily by using a function T brackets or this. So here just an example. Again, this is operator column from 23 to 31 and creating all the sequence of numbers here. And also a vector of 3 numbers, B plus a value, and then we print if this the result, the evaluation, logical evaluation of this expression, if B is in A, so 27, as you can see, is as part of vector A, the result is 2. Okay, so I'm going to exclude this part as I didn't mention much matrices yet. So today actually we worked through the vector and also the question on individual coursework. Happy to help you for any question. Thank you.